So a little bit more on metals. So metals are good conductors of heat and electricity. So we can see here some examples of copper wiring. So if you strip away copper wire, the outside of it is plastic that does not conduct heat or electricity, but inside the copper wire does conduct heat and electricity, or most importantly, electricity. So it's used in wiring, in lights, in external wires out in the streets. And so this is also an example of power lines, metal used in conducting the electricity that are power lines that bring electrical energy into our homes. We'll be talking more about electrical energy and how it's generated in a future chapter. So metals are good conductors of heat and electricity. And let's take a look at this actually. I've got this piece of aluminum foil. So this is just aluminum foil from the kitchen. It's pretty flat, but this is metal. It's to the left of the stair-step line, and it will conduct heat or electricity. But what I have here is a flame. Let's light that again. And this is hot. It's a hot flame, and I will hold it up to this aluminum. Now, if you've ever put a metal pan on the oven or in the stove, that metal pan gets hot. So I can tell you that I'm holding this, and on the other side of that, I can feel, ooh, that's hot. Because the heat, though it's on the other side of this and my finger's not going to catch on fire with the flame, the heat is conducted. That heat energy I can feel on the other side. It's conducted by this piece of aluminum foil because aluminum's a metal. So you have to the left and below of this stair-step line. So this would be the stair-step line, these elements in pink. To the left and below are metals. Okay, so those are all in green. To the right and above the stair-step line, that's in blue. Those are all non-metals. On the stair-step line itself are called semi-metals. They're halfway between being metals and non-metals. They're also called semiconductors, and they're also called metalloids. So the semi-conducting is that they can partially conduct heat and electricity. They can conduct electricity in a controlled manner. And so that's what happens, is that they are you can control the amount of electricity passing through, and that's why silicon, this is in pink, that's one of the metalloids, the semi-metals, the semiconductor. Silicon is used in computer chips because you can control the amount of electricity passing through. Now, if you've ever had a hard drive burn out on you, it literally also conducts heat in a controlled manner and will get too hot. So that's why laptops have internal fans, or desktop computers also, to cool off the heat that's being conducted inside of a silicon chip. So back to smartphones. How do touchscreens work? Well, they're not just glass, but they are layers, remember, of different materials. So here's your smartphone, and you take all those layers apart. And so at the very top layer, this is what you touch, is this protective anti-reflective coating. So that's important to know that you are protected from all of this down below. You're not going to get any electrical shock from it. You're not going to be, exposing yourself to dangerous metals or chemicals. Okay, so one layer, a couple layers just below that. So you can see there's a protective cover, a bonding layer. A couple layers below, though, are these lines. You can see horizontal and vertical. These are lines, are driving lines and sensing lines, and they are metal that have an electrical current flowing through them. Now, how do they have the electrical current flowing? Because these lines are made out of metal. So when you have a conductive object that touches the screen, like your finger pushes down on the screen, this disrupts that current, and your finger will conduct a tiny bit of electricity. And so you're not going to get, any kind of shock from it, a very, very tiny bit. But when a conductive object, so that has to be skin from your finger, if you've ever noticed when you're wearing a glove or fabric, doesn't work, but a stylus will work. Okay, so it has to be a conductive object, will conduct a tiny bit of electricity and allow this portion of the grid to be recognized by the computer that then says, all right, this is the on button. So this is smartphones require metals in these sensing lines and driving lines that conduct electricity, but also in a lot of the other parts. So for the touch screen, but also the processor chip I mentioned uses silicon, and there are also small transistors inside. So the metals, most of the common metals in a smartphone are generally rare. Rare earth metals are needed in smartphones, and what that means is they are usually from really rare random places on Earth, all over the world. So they have to come from exotic locations, and from those exotic locations, these metals are not just open, they have to be mined, they have to be dug out of the ground, and then those metals also have to be processed. They have to be separated from the soil that it was dug out of. So this is all very energy intensive. The rare earth metals generally come from China. So China, but a lot of other countries in Africa, this is the purple. But though we are one of the biggest users of smartphones in the United States, the rare earth metals don't come from here. So China controls the world supply of rare earth metals. They're also the supplier of the smartphones. But it's one of the many issues concerning sustainability of smartphones. It's also in this week's discussion topic. And it's also why recycling of smartphones is important. The cradle to cradle notion we talked about last week in lecture will allow for reusing and recycling those metals, the rare ones in particular, to be used in new electronics.